Welcome to Zoom in Data. In this session, we will understand Databricks clusters, which are the core execution units in Databricks. Every notebook, job, and workload in Databricks runs on a cluster. Having a strong understanding of cluster concepts is extremely important because interviewers frequently ask questions related to cluster types, configuration, and usage scenarios. By the end of this subtopic, you will clearly understand what Databricks clusters are, different types of clusters, how clusters support scalable data processing. Subscribe to Zoom in Data for more structured Databricks learning. What is a Databricks cluster? A Databricks cluster is a group of virtual machines used to run data processing workloads. Clusters provide the compute power required to execute Spark jobs, notebooks, and pipelines. Each cluster consists of a driver node and one or more worker nodes. Why are clusters essential in Databricks? Clusters act as the execution engine for all Databricks workloads. Without a cluster, notebooks, jobs, and pipelines cannot be executed. The choice and configuration of clusters directly affect execution speed, reliability, and operational cost. What are the core components of a Databricks cluster? A cluster consists of a driver node and one or more worker nodes. These nodes communicate with each other to distribute and execute tasks. Together, they enable parallel computation across large datasets. What is the role of the driver node in a cluster? The driver node is responsible for coordinating the execution of Spark jobs. It converts user code into execution plans and distributes tasks to worker nodes. The driver also collects results and manages the Spark application lifecycle. What is the role of worker nodes in a cluster? Worker nodes execute the actual data processing tasks assigned by the driver. They process partitions of data simultaneously, enabling parallel execution. Worker nodes handle memory usage, disk operations, and intermediate results. What are the main types of clusters available in Databricks? Databricks provides all-purpose clusters and job clusters. Each cluster type is designed to support different workload patterns. Selecting the correct cluster type improves efficiency and cost management. What is an all-purpose cluster and when is it used? An all-purpose cluster is an interactive cluster designed for development and exploration. Multiple users can attach notebooks and work collaboratively. These clusters are commonly used for testing, debugging, and ad hoc analysis. What is a job cluster and why is it preferred for production? A job cluster is created automatically when a job starts and terminates after completion. It ensures a clean and isolated environment for each job run. Job clusters are cost-effective and ideal for scheduled and production workloads. How do Databricks clusters support distributed processing? Data is divided into smaller partitions across worker nodes. Tasks are executed in parallel on different nodes. This significantly reduces processing time for large datasets. What is autoscaling in Databricks clusters? Autoscaling dynamically adjusts the number of worker nodes based on workload demand. When workload increases, new nodes are added automatically. When demand decreases, unused nodes are removed to reduce costs. What is auto-termination and why is it important? Auto-termination shuts down clusters after a period of inactivity. It prevents unnecessary cloud costs caused by idle clusters. This feature is especially useful in development and testing environments. How are clusters created in Databricks? Clusters can be created manually using the Databricks Workspace UI. They can also be created automatically through jobs and APIs. Configuration options allow users to control compute size, runtime, and scaling. What is Databricks Runtime and why is it important for clusters? Databricks Runtime is a pre-configured environment that includes Spark and optimized libraries. It provides performance enhancements and security updates. Different runtimes are optimized for analytics, SQL, or machine learning workloads. How does cluster size impact performance and cost? Larger clusters can process data faster due to increased parallelism. However, oversized clusters increase costs without proportional benefits. Proper sizing ensures a balance between performance and cost efficiency. How does Databricks handle node failures within a cluster? Databricks automatically replaces failed worker nodes. Spark retries failed tasks whenever possible. This ensures fault tolerance and uninterrupted job execution. How do clusters interact with cloud storage systems? Clusters access data directly from cloud object storage. Storage is independent of the cluster lifecycle. This allows clusters to be temporary while data remains persistent. How does cluster configuration influence operational cost? Instance type selection directly affects pricing. Autoscaling and auto-termination reduce idle resource usage. Proper configuration helps organizations control cloud spending. How is security enforced at the cluster level? Clusters operate within secure cloud networks. Access is controlled through IAM roles and Databricks permissions. Data is encrypted during processing and transfer. What are shared clusters and their use cases? Shared clusters allow multiple users to use the same compute resources. They reduce infrastructure costs in collaborative environments. Shared clusters are commonly used for development and learning purposes. What are single-user clusters and why are they important? Single-user clusters are dedicated to one user or service identity. They provide better isolation and security. These clusters are ideal for sensitive workloads and production jobs. How does cluster selection affect job execution reliability? Job clusters ensure consistent execution environments. Interactive clusters are better suited for experimentation. Choosing the correct cluster type improves job success rates. How are logs and metrics generated by clusters? Clusters generate detailed logs for drivers and workers. Metrics track CPU, memory usage, and task performance. These insights help diagnose failures and optimize workloads. How do clusters support machine learning workloads? Distributed clusters enable parallel model training. ML-optimized runtimes include required libraries. Scaling clusters reduces training time significantly. Why are Databricks clusters a common interview topic? Clusters demonstrate understanding of execution architecture. Interviewers assess how candidates optimize performance and cost. Strong cluster knowledge reflects real-world Databricks experience. What are best practices for working with Databricks clusters? Use job clusters for production workloads. Enable auto-scaling and auto-termination wherever possible. Regularly monitor performance and optimize configurations. Thank you for watching Zoom in Data. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos coming soon on Zoom in Data. Stay connected and keep learning with Zoom in Data.